Okay, now we are recording. So, strings, right? We've talked about strings. We've seen them sometimes in our previous examples. Basically, a string is a kind of object used primarily for storing, extracting, and reusing text. So that's the data that's stored in a string, is just a long slug of text. Technically, it's an array of type char, so it's a sequence of characters. But because it's as an object, you have specific methods you can use that you couldn't with just an ordinary array of characters. Now, string is probably the single most used object type in Java, and accordingly, there's a lot of quirks, right? This is analogous to anything with languages. Simple words, basic words, foundation words of a language tend to have a whole lot of different meanings. It's kind of the same way with string. Because it's so foundational and so widely used, it's kind of become a bit of a Swiss Army knife class. So there's a lot of special things about it. Anyway, first off, that's a little odd. String is a final class, right? So if you actually go up and look up the class definition for string, which you can find online, you'll find in the class header it says final class string. That means you cannot make subclasses of string. So you can make other classes that contain an array of characters and create your own custom methods for working with that, but you cannot make a subclass of string itself. Okay, this is conceptually similar to final with numeric variables. If you use final for a variable, it means you can't change that variable, right? If you make final for a class, you can't change the class. And basically, if we made a subclass of string, we would be saying it's a different special kind of string. And when it's final, you can't do that. In fact, we'll pop out here for a moment. If you ever want to look up these classes, by the way, right, you can Google something like Java string class. And you can find over here on Oracle, right, the docs on Oracle, you can find the original code for the class itself. So all this kind of stuff, there's a string, right? If we look at the top here, right, java.lang.string, that's the class. Here's the header, public final class string, which extends object, so it's directly from object, implements some things, interfaces, we'll talk about those later. And then you can look down and see, oh, here's the fields that it has, right? You can't really look at that directly. Here's all the constructors. Here's a bunch of different methods, okay? Field detail, all right? So we have a comparator, right? So fundamentally, it's a sequence of objects, but it contains a bunch of character data, all right? And then if you're more methods there in some detail. Comparators, we don't really get into this class. If you take IDS 401, you might. If it ever happens that I go back to teaching IDS 401 again, then you would also get it there. But comparator, it's one of a set of list type things. So basically arrays with special functionality added onto it. All right, but anyway, if you ever want to look at all the different things that are in these classes and what they can do and stuff like that, yeah, you can just Google, you know, Java class and then the class name, and you'll get to one of these Oracle pages that has it. Okay, so that's strings. Now, how do you declare it? How do you create one? Well, declaration, right? Just like we've seen, the type and then the name of the object or variable. So if we declare something like string S, then the ID is going to know there from that point, S is an object of type string. Now, there's two different ways you can create a string. One is with the standard keyword new. It's going to create an entirely new object. The other one is you can create a string from a literal. And what this actually does, it's a little bit weird. So we're going to drop into Paint for a moment and talk about it. Okay. So suppose we have an area down here. This is memory. And wherever we're doing stuff, let's see, we have our literal string, hello, that's stored somewhere in memory. And then a new string stored somewhere else. Okay. Now, if I do this command, I'll write them both in black, I guess. If I do string s equals hello, what happens in Java, right? I'm going to put the notes here on the side. First, the literal string itself is created in memory. Okay, that's the first thing that happens. So this hello actually is created first. Then number two, S, that reference points to the literal string. Okay, so initially what happens, number one, this, okay, and then subsequently, this also will point to the same point in memory. Okay, so anytime you have a literal in your IDE, that's going to be created as a thing in memory. When the code is compiled and the program runs, it's going to be automatically created, and then S will just point to that literal string. And in fact, if you make another reference later on, like for example, I guess I'll keep it black. Like if I subsequently do string T equals hello, well, guess what? This hello is, of course, right, you know where I'm going with this. This hello is the same as this. Therefore, this T is the same as this, right? So they're all going to be pointing to the same thing. This hello, that hello, they're both literal strings stored in memory somewhere. S points to that, this T points to that. They're all pointing to the same thing in memory. They're the same object. Okay? And the reason why we do this is potentially a large savings in memory space and time for creating new objects, right? It takes a little bit of time to create each new object. If you don't have to do that, why do it? Make your program run a little faster, okay? On the other hand, get back to black here. If we do this, right? String S equals new string hello. Okay, that, since we've created a new string, it's going to point to that new object. But if we create another one, and I'm running out of colors that I want to use, I'll use dark blue, I'll use purple. We'll see how that goes. Okay, if I create a new string, string T equals new string, once again, hello. I'm trying to move this thing, there we go. Okay, that's going to be created at some new point in memory, right? Again, we'll have a new string hello, and it will exist independently of memory of any of these other things. So if I specifically invoke it with the word new, I'm actually going to create a new thing in memory. Okay, so the importance of it, if I do it this way with literals, say multiple, I'll say reuse of the same literal means referencing the same string object, okay? With the word new, each string object is separate. Okay, and this will be important when we do tests like whether objects contain the same values or whether objects are in fact the same object. Okay, so that's coming right around the corner. So understanding this is going to save you a little bit of headache later on with some of the assignments that we're going to be doing. Okay, let's take a moment. Questions about this? Does this make sense? Questions? Seems very clear when I'm just talking about it.
Professor, can you hear me?
I can.
I had a question. I guess why would you make a new string, like the new string T instead of hello, instead of referencing the old or the one that was there previously?
Oh, well, one reason why you might do that, okay, is just in your code, you want to make it not point to the same thing in memory. Because you understand that later on down the road, you might have it be something different. Or the class is independent from others, right? It could be, That's the most likely thing, I suppose. These two strings that you created, they're actually created in separate classes, right? And when you're writing the classes, you wouldn't necessarily know that they're going to be combined together in a program. I'm not sure, maybe,
Thank you.
yeah. So basically, there's not really an advantage to creating it as a new string. Okay, because yeah, if I say large savings in memory space, creating time for new objects, yeah, there's not really a compelling reason to use this over this. As we'll see in a second, one of the strange things is anytime I change a string, it's actually going to create a new string object. You can't actually create strings in space, in place. So there's not really an advantage to making it a new string. Yeah. Okay. So unless the reason would be if you're not going to immediately assign it a value, that would be one possibility. If you just want to say, okay, this is a new thing, but I'm not immediately going to assign it anything. Yeah. Okay. We'll talk. Maybe it'll make more sense in a second. Okay. So follow up with this. So again, there's two ways to do it. Standard using new, and then the other one is from literals. So the quirk in Java, anytime you create two strings from the same literal, they're actually going to be the same object. So the literal string, like I said, created as an object first, then the other strings share the reference. Now, another oddball thing about strings is they're immutable. They're immutable, but they're not final. Well, what does that mean? Okay, let's put this back into Paint. And this is where things are going to get weird. Okay. Strings are immutable, but not final. Okay. So by default, you could, of course, create a string that's as final, right? You could declare it final string, whatever, but in general, they're not. So final means you can't change the string contents. But immutable means you can't change the contents in place, right? Basically, that means that is by changing a string, you create a new string object at another point in memory. Okay, so what happens, again, we'll draw a block for memory. If I have an initial string, right, let's say hello, and I have some code over here, string s equals hello. Of course, initially s is going to point to that hello in memory, right? But if I then say s equals goodbye, then this goodbye is going to exist, right? It's going to create that goodbye. S is going to point to this. It's not going to overwrite this hello, right? And fundamentally, the reason for that is memory management. If I have to hold this space, right, what happens if the string is longer than the amount of space I've reserved? I have to shuffle a bunch of stuff around. And if it's not exactly that space, then the problem is, well, I end up with a lot of, Swiss cheese type holes in my memory. I end up with space in memory that's reserved for actions, but not actually being used. The final thing, right, if I change this contents in place, suppose I have two strings in separate classes that happen to contain the same text. Okay, well, if they were both created from literals, they would be the same string, and changing one would change the other. Well, what's the problem with that, you ask? Well, imagine if one of those strings is something like, I don't know, just random pointless text like a username, and another one happens to be someone's password, right? If I have them both in memory at the same point, and then, you know, a password gets changed, or another string changing one string changes someone's username, things like that could really throw a wrench into your whole day. So in order to make sure that, you know, strings are reasonably safe to use in this way, anytime you change a string, it creates a new string object, right? Again, unless that string already exists somewhere in memory. So if goodbye already exists in memory, I can switch over to that. But otherwise, if it's some, you know, DPE, doesn't previously exist, and I switch over to that, then it's going to be a new string. Okay. So strings are a little strange, is the key takeaway. Most variables, for example, if you change a numeric variable, it remains at the same memory location, because if you change an int value, well, it's still going to be an int. It's still going to occupy 4 bytes. But with a string, there's no guarantee that the thing will be the same size, and you want to worry about other classes, other parts of the application accessing that same memory. So yeah, you end up creating a new string anytime that happens. Okay. Well, I'll add this. One thing that's a possible, so you ask, why would you create something that's a new object? One thing is this, multi-threading, okay? If you have multiple processes accessing the same data, they may have to wait on each other. Okay, so in particular, if you have multiple references pointing to the same spot in data and doing something with that, they can interfere with each other. Okay, but if you use the new keyword, then your strings won't be at the same point in memory and simultaneous access won't interfere. Won't interfere with accessing them. Okay, so that's one thing. It's kind of an advanced thing, multi-threading. But yeah, that's one reason. But at the scale we're using, it really doesn't make much difference. The memory concerns are trivial. We're not really doing multi-threading, so that concern doesn't really matter much. It's only when you get to big, complicated programs that there's a lot of stuff going on, and you really have to super optimize them, that things like that become an issue. Okay. All right, so back to this. So again, strings are immutable but not final. You can change a string, but you can't change the contents on it. Okay, so for example, let's do this. Let's actually go over to Eclipse now. I'm going to make a string. Okay, so we'll have string s equals, we'll do it hello. Okay, and then string t equals s. All right, so right now we can say declare s, create it from literal. Okay, then have t reuse, right? Have t share the same reference. Okay, so t is s. We're saying they are the same thing. All right. But what happens if I do, let's say, update s? So if I say s equals goodbye, and let's print them both out. See, they changed. And this is not how objects normally work, right? Normal circumstances, we would say, if T is S, right, then they're the same thing. And changing S should also change T. So this little program that I wrote, this upsets everything we've learned about Java, but it's really very specific to strings. Okay, so key thing is update S. I'll say because strings are immutable, this update to S creates a new S, but doesn't inherently change T. Okay, and we can prove that, like I said, when I print this stuff out. So again, this will be important for some stuff we do in the assignments where we're working with strings and we're testing basically whether they're the same object or whether they just hold the same contents or we have multiple objects sharing a reference. So just so this doesn't totally freak you out, right? Because again, like all the stuff we've learned before, we would think, well, yeah, I changed this thing, I should also change the other. Doesn't work that way for strings. Okay. Questions on that?
You just said when I guess when you change the S to goodbye, it created a new string. Is there
Correct.
source code for that, or is that just done in the virtual machine?
That's done behind the scenes, right? So there's all this stuff under the hood that happens in Java when we create something. But if we want to do a quick walkthrough of the steps, right? What happens, the first thing, I'm going to just put these things in there. So when we even compile the program, we get these two strings in place because they're literals. So when we say string S equals hello, right? That points here, right? We say, okay, there's S, you're pointing to hello. When I do another one, if I do like I did, I say, whoop, let's have that be black. String T equals S, right? There's still, it's pointing to the same thing in memory. I'm pointing down here. But when I do the next command, the next statement, which is S equals goodbye, then what that means is this action, right? This is all gone away. I'm trying to go through that, but it's not as easy as it looks. That connection is broken, and instead, S now points to here. But the connection between S and hello is not broken. That still remains. Okay, so down in the guts of your machine, that's what's happening. And again, that's specific to strings. Normally, what would happen is this. If we had two objects, right? Suppose we had an object, a class, I don't know, class thing, and thing has an int x. Okay, if I do thing t1 equals new thing, right? And then t1.x equals 5, then that creates some t1 down here. It exists, and with its attribute t1.x equals 5. And of course, t1 points to that. Okay? If I make another thing object, like thing t2 equals t1, okay, again, t2 is going to point over to this same thing, right? They're the same thing. If I again make the next statement t1.x equals, say, 3, that's going to change the attribute here, t1.x equals 3, but it's not going to change t1 itself. This t1 is still going to be sitting at the same place in memory, thus t2x also is 3, right? Because T2 is reading it from the same point. This thing class is not immutable, so I can change its elements in place. I can update the elements without creating an entirely new object.
One last question with the
Sure.
string. You change string T, change string S to goodbye. If you were to change string T to something else, the hello would, I guess, be trash or disappear.
If there were nothing else using it, then yeah, it would be garbage. Garbage is the technical term.
Okay.
Yeah, and right, if it's something floating there in memory and nothing else is using it, then yeah, it becomes garbage, and eventually the garbage collector is going to come around and pick it up. Yep. Okay, well, good. Anything else? Okay, well, anyway, so yeah, reasons why strings are immutable. Number one, it's good for security. If you have multiple classes accessing the same string, you wouldn't want them to access the same literal string and have a change in one affect the other. Likewise, it's generally better for multi-threaded applications, because if the different objects are pointing to different places in memory, there's going to be faster access to them, as opposed if you have a bunch of processes all accessing the same point in memory, that could potentially really slow things down. Okay, anyway, if you want to look at a little more about this, I did post a link in the slides, but I don't know. Some of that's kind of advanced, so you might read that and be like, oh, I don't know, it doesn't make sense. But, you know, the simple reason why this is enough to go on for now. Just basically, we have strings for better security and to allow multi-threaded applications to run faster. Okay. Or more securely. Now, indexing. So every string contains, in effect, an array of type char. The minimum length is 0. You might not have any in there. That would be what's called an empty string, or a length 0 string, or a size 0 string. The upper length bound is really big. Theoretically, could be up to about 2 billion. Although if you try to display large strings in the console, some weirdness starts to happen way before that. You start getting much past 10,000 and they start not displaying correctly in the console. Okay, we haven't talked about arrays yet, but if you've seen them in other programming languages, indexing starts at 0. This is a very common convention in programming. So the first character's index is 0, and then for a string with n characters, the last index is n minus 1. So for example, if we have this literal string hello, obviously it has 5 characters, hello, so the length is 5, and the character at index 0 is h, and the character at index 4 is o. Okay, so this is our indexing model. Go ahead, I'm gonna make a box here and try to divide it approximately into fifths. Good enough. Okay, so here's the index. Down here, the contents. Right, and it's a thing of type, oh, there we go. It's a thing of type char. So over here, I just do it up here. 0, whoop. That's weird. I just do it this way. The tab character was acting very strangely if I was hitting the tab key. Okay, so here's the index, and then the contents, right? H, I'm doing the quotes for character. I'm trying to. Okay, so that's how the string array is stored. Okay, and whatever, so a string with length 5, a string with length 5, the last index is 4. More generally, a string with length n, the last index is n minus 1. Okay, so that's how the indexing works. I can find any stuff that's in there. We'll have much more to say about this when we get to arrays. Okay, now there's a whole bunch of methods for strings, and we scanned through a few of them when we looked through, you know, the string class, and you could see, wow, there's a lot of methods there. Again, this is the one we looked at, so that was it. But we're only going to do a few here. We're going to do char at, length, index of, substring, and starts with and ends with. So let's go ahead and start with char at. So the first one, char at, requests the character at a particular index. Okay, what are the arguments? What is it returned? Well, you have to, when you call this method, you have to send along an argument that's an int, right? So you read a specific element from the array. So it represents what index you want to read from. And then the method returns a character. For example, if you have a string hello, then the method call s.char@1 would return e. Okay, we can do this in, again, let's do a different method. So this, I'm gonna copy all this out and put it in a different method. So static void, I don't know, we'll call it toStrings. Okay, but I don't have to call it. By the way, if you ever want to shift a whole bunch of text one direction or the other, okay, there's a handy thing there. Okay, we'll do another method then. Let's call it static void get char. Okay, and we'll say we'll send along an int index and a string. Yes. Okay, so suppose I have string s equals, what shall we call it? We'll call it I don't know. I'm Vancouver. That'll do. Okay. And we want to find what's the fifth character in Vancouver. Okay. Well, we could call our get char method. We could call get char, and we send along the index, what did I say, 5, the fifth character. So the thing at index 5, or that would be the sixth character. Okay. Anyway, we'll do the thing at index 5, and then the string will be s. Okay, so then when I receive that over here, I receive that request. Okay, I'm going to return something. I'm going to return a char. So let's say char c equals that. And this will just return s dot get char, char at, sorry. Char at index. Okay, so do another one. Let's do get char 0, comma s. Okay, and then c equals that, and we'll output them. Okay, so you know what we can do here? We can actually put the text in here. So we can say something like system.out.println the character at index from string s is, okay, plus s dot char at index. Okay, so we can just read that. So the first one will say index 0 from Vancouver should be a capital V. Index 5 should be this lowercase u, right? It's the sixth character, but index 5 is the sixth character. So let's see how that goes. See if I made a horrible mistake, and see what's this error that I have here. Let's crunch that down. Plus is plus. Oh, I need an extra parenthesis. Okay, going on. Okay, character at index 0 is V. Character at index 5 is lowercase u. Okay, questions on that? That's our get char method, right? So get char, or char at rather. Char at is a method for a particular string. So first we have to somehow recognize what string we're talking about, call its char at method for a particular index, and that will return whatever character is there at that index. Okay, let's do a couple more then. So Uh, Next one, length. Length is super easy. So all that is the number of characters in a string. It doesn't require any arguments, sends along an int, right? So for example, given the string s equals hello, calling its method s.length would return 5, okay? Likewise, let's do, go to Eclipse. If we wanted to, we could do, how many characters are in Vancouver? Well, Vancouver, 9 characters, right? So the length is 9. So if we do system.out.println s plus has s.length characters. Okay. Of course, it has 9 characters. Now you can have an empty string, right? If I wanted to, I could do something like s equals that. Then how many characters are in there? There's 0 characters. There's nothing between the quotes, right? And that's a legal way to have a string. So if I run this, it'll say blah has 0 characters. See, it didn't even print anything there. It just made room for the space. The space is actually this one here that's shown. Okay, so that's an empty string. Empty string has length 0, but it's totally legal. You can have a 0 length string. Okay, now, important point here on the topic of visibility. All right, so fundamentally, this is not exactly what's going on, but this is enough to talk about at the moment. Imagine if string has a private array of type char, okay? So we have class, string, blah, 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 right? We could even add final class string, do that. Okay, and suppose there's a private array of type char. Okay, we'll call that C. Because it's private, I can't actually access it from the outside. No other outside class can read directly what that the contents of that is. Instead, I have to go through other methods. So for example, I might have a method int length return C dot length. So every array has a length attribute, but in this case, because it's private, because the array is private, another class cannot see this value, right? This length value. I can't actually directly access that array from the outside. Instead, I have to go through one of string's methods. And that method, because it's part of string, can access the array. Okay, so this is how come, again, common mistake, people will try to do string.length as reading an attribute, not a method call, right? So if I tried to do just s.length, this will give me an error. I read over here, it'll say length cannot be resolved or is not a field. Yeah, it doesn't exist, right? It's actually a method call that I use to be able to read from this private data belonging to the string object. Okay, questions on that? Maybe we'll do one more. We've got a few minutes. Sure, why not? Okay. You know what? This last one is a little complicated. This index of is a little tricky. So I'm actually going to defer this till Friday. So I would say if you have any questions, right? So let's do a quick thing with what we've covered. Yeah, I do. Some people do have some stuff. Let's do a quick thing with what we covered, and then I'll answer questions. So I'm going to stop sharing. Boom. Okay. So key takeaways. Number 1, okay? Strings can be created from literals or as new objects, okay? And they can behave differently. So, of course, they're both still strings, but, you know, a literal exists there in memory. Anything else automatically shares that one. A new is created a separate point in memory, and they have some advanced properties that are useful. But in IDS 201, it's not really going to matter. Number 3, what is the follow-up from that? Anytime you change a string, a new string is created in memory, right? Assuming it doesn't already exist as a literal, in which case you just reuse that reference. Okay. Number 4, string has indexing because it includes an array of characters, of chars. Okay. For A, indexing starts at 0. For B, indexing ends at length -1. Okay. Then 5, string methods. We covered char at, which gets the character at a particular index, and then 5b length, which returns the otherwise inaccessible length of the string. Okay, so those are our takeaways. Now I saw there were a couple questions, so I'm going to throw in an answer here. If you were to add t equals s after s equals goodbye, would that change t at all? Yes, at that point, t would also point to s. Okay, so here we have this example, right? We had our case, s equals hello, the literal string hello, t equals s, so they both point to hello. If in my code here, right, I'm going to go back to sharing. Right down here, so we have s equals hello, t equals s. If I do s equals goodbye, of course, s will point to that new literal goodbye. If I follow up with t equals s, then yeah, then t is going to change to goodbye as well. And at that point, since nothing is referencing this hello, then hello will be garbage and eventually picked up by the garbage collector. So if I run this, right, if I do, I'll just tack on a method called a toStrings here, and then we'll see the results at the end. Okay. See, both S and T are saying goodbye. Okay, it works the same way. All right, good question. All right, so we're about at the end. If anybody has any questions, I will, stick around for a minute to answer them, but this is the conventional end of the lecture. So, hello.
The assignment is due on
Hold on,
Friday
there's
the 25th, right?
Things. Hold on.